Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for SAT. We have been solving SAT math problems out of this book here, the official SAT study guide. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 891. Please turn to it, 891, and today is our lesson number 125. The two problems that you see on the next column, second column, number 17 and 18 are the ones that we are about to do. The two problems that you see in the left-hand column, number 15 and 16, that is something that we did yesterday. Oh, that reminds me, I meant to do this thing, what I'm about to do, I was going to do that in the previous video. I forgot all about it. It is something that I wanted to do in the video before that. I'm going to quickly take care of it here because it's bothering me. Turn to page number 890 very quickly. Number 14. And that one was day number 123. In that problem, I'm going to quickly take care of one thing that I forgot to take care of when I was doing the problem, and I forgot to do it yesterday also. Is that the right one? 890? No, that's not it. Oh boy, this is from day 122. This is farther back than I thought. 122, number 8, on page 888. I'm going to quickly take care of it. Turn to page 888. Turn to page number 888, problem number 8, which is the very last problem of the multiple choice questions. It is supposed to be a hard question. Now in that question, if you turn to the page, you will see it says that the rectangle ABCD lies in the XY coordinate, and then they are hell-bent on telling you that its sides cannot be parallel to the axis. In other words, if here's your XY coordinate, the rectangle that they're talking about, you're not allowed to draw it like this. This side cannot be parallel to y-axis, this side cannot be parallel to x-axis. The question is, why did they bother to say that? Why did they insist that these two sides cannot be parallel to x and y axis? X and y axis. But the reason is very simple. Because they're asking us, what is the product of these four lines? Well, in this case, in this scenario, the slope of this line is 0. If slope of this line is 0, it doesn't matter what the slope of all other three lines would be, because 0 times anything is 0. So here's a word that comes to my mind. I'm not sure. I am not sure at all if we have learned this word in our vocabulary lesson or not. I highly doubt it, because I don't recall covering the word. I do not recall having covered this word. Oh, what do you know? It has been covered in our vocabulary lesson, day number 52. If you type in vocabulary, day 52, you will see a video in which you will learn this word. What does it mean to obviate? Obviate means to make something unnecessary, to make something redundant, to make something not needed, not required anymore. So to obviate, to eliminate, to make it unnecessary, to eliminate the existence of this scenario, to obviate the existence of this scenario, where if one side happens to have a slope of 0, most people will immediately realize that the product of all four sides will be 0. Product of the slope of all four sides will be 0, because you won't have to worry about the slope of the other three sides. It doesn't matter. Slope of this line is 0 and slope of this line is 0. They don't both have to be 0. As long as slope of one of these four lines is 0, the product of all, because then that question they're asking us, what's the product of the slope of these four lines? Well, in that case it will be 0. So to obviate that scenario, they insisted that this is not allowed. We have a rectangle, but it cannot be parallel to x and y axis, which is why we had to draw our rectangle something like this. This is perfectly allowed. This is perfectly fine. It's a rectangle, but the sides are not parallel. This side is not parallel to y-axis and this side is not parallel to x-axis. Okay, enough of that. I feel better now. It's out of my system. I feel better. We can go on. Problem number. We are on page number 891. Problem number 17. Alice and Corinne stand back to back. All right. They each take 10 steps in the opposite direction, away from each other. Okay. So Alice takes 10 steps, and Corinne takes 10 steps. I'm using A to represent the length of Alice's step, and I'm using C to represent the length of Corinne's step. One more time. They each take 10 steps in the opposite directions away from each other and stop. Alice then turns around and walks towards Corinne and reaches her in 17 steps. The question is, the length of one of the Alice's step, if the length of one of the Alice's step is how many times the length of Corinne's step? Interesting. All of Alice's steps are same length and all the Corinne's steps are same length. In other words, they're telling you that these steps that they're talking about are standard unit. They are always the same. Alright, fine. So we know now that 10 of these and 10 of these, the amount of distance that is covered when she walks 10 steps this way, and when Corinne walks 10 steps this way, they are this far apart from each other, and then Corinne turns around and walks back, and that happens to be, this distance happens to be 17. So who walks around, Corinne or Alice? I forgot. And they each take 10 steps in opposite directions away from each other and stop. Alice then turns around and walks towards Corinne. So it is Alice who is walking. So 17 of Alice's step are the same distance as 10 of Alice's step plus the 10 of Corinne's step. That's it, that's your equation. And the question simply is, the length of one of Alice's step is how many times the length of Corinne's step. In other words, they're looking for the ratio of A to C. We are looking for the ratio of A to C. Let's do it then. Enough said. Let's do it. Bring all the A's on one side, subtract 10A from this side, 10A from that side. Positive 10A and a negative 10A will drop out, which was the whole point, and we find that 10C equals 7A. And the question is, the length of one of Alice's step is how many times? So let's solve for A. Divide both sides by 7. And we find 7 drops out, and we find that A equals 10 over 7 times C. Voila. The question is, the length of one of Alice's step is how many times the length of one of the Corinne's step? The answer is, it is 10 over 7 times. That's it. Don't mess with it. Don't try to convert into mixed fraction or decimal. You'll be wasting your time. It'll be making your life miserable. These are gradient questions. As long as you can fit in the answer in the space that is provided to you, leave it alone. Don't mess with it. And this will fit. Type it in, gradient it as 1, 0, /10. That's how your answer should look like. Nothing more than that. Don't waste your time. That's it. One of the Alice's step is 10 over 7 of Corinne's step. Number 18, the last one. Let the function f be defined as x squared plus 18. Alright. If m is a positive number such that f of 2m equals to 2 times f of m, then in that case, what's the value of m? So let's find out, shall we? Let's first find out what f of m would be. F of m would simply be, wherever we see x, we replace it with m. So it will simply be, instead of x squared, it will be m squared plus 18. Similarly, f of 2m would be, wherever we see x, we replace it with 2m. So it becomes 2m squared plus 18. And we are told that these two quantities are equal to each other. So let's put them equal to each other and see what happens. Oh no, they are not equal to each other rather. One is 2 times the other. I'm not reading carefully. It says f of 2m equals 2 times f of m. So let's find out, shall we? F of 2m we found out is this guy here, 2m squared, which is same as 4m squared plus 18 equals, it comes right from here, equals 2 times f of m, which is right here, m squared plus 18. Let's open the parenthesis, 2 times m squared, and then 2 times 18, which is 36, and here we have 4m squared plus 18. Let's subtract 18 from both sides, and let's subtract 2m squared from both sides. So here we have positive 2m squared, here we have negative 2m squared. Positive 2m squared will cancel out the negative 2m squared, which was the whole point. And similarly here we have positive 18 and negative 18 will drop out. And here we end up with 4m squared minus 2m squared. 4m squared minus 2m squared will be 2m squared, which boils down to 36 minus 18, which is 18. We want the m by itself because we are interested in finding the value of m. Divide both sides by 2, and it turns out that m squared equals 9. We're not done yet. They're looking for the value of m. I shouldn't have put a box around it yet. They're looking for the value of m. M squared is 9. If m squared is 9, then that implies that m has got to be either positive 3 or negative 3, because both positive 3 and negative 3 squared will give us 9. So m is either positive 3 or negative 3. The question is, which one do you grade in? The answer is, it's bloody well be positive 3, because there is no way to grade in a negative number in a grade in question. That's your cue. If you solve a grade in problem and you come up with the answer of negative 3, that answer is wrong, because there is no way to grade in a negative number. They do not allow for that. So then how do you know that we cannot, they have to say something in the problem which makes positive 3 legitimate and negative 3 not legitimate. Well, they tell you in the problem that m is a positive number. If you read the problem properly, it tells you that m is a positive number. Therefore m equals 3. That's it. That's our answer. M equals 3. I will see you tomorrow when we'll begin the next section. Section number 5 on page number, I don't know what page number it is, section number 5. Okay? I'll see you tomorrow. Bye now.